Hello, everyone. I hope you're doing well today. For those who just arrived or those who haven't introduced themselves yet, please feel free to type in your name in the chat box, where you're from, and what company, university, or organization you're representing. Welcome to you all. I hope you're having a great week so far. Again, good afternoon to all our participants. I am Emily from SuperMap. I would like to acknowledge our host university, the Mindanao State University Iligan Institute of Technology. Say hi in our chat box, please, students and faculty of MSU IIT. And to everyone here, it is my pleasure to welcome you to this webinar entitled SuperMap GIS Technologies in the Era of Big Data. To jumpstart our event for today, let us hear some opening remarks from Dr. Noel R. Esto-Perez, Dean of the College of Engineering and Technology of Mindanao State University Ligan Institute of Technology.
Hello, a pleasant good afternoon to everyone, to our participants for this a very big event, no? As big as the big data. The SuperMap GIS technologies in the era of big data by SuperMap. We are very grateful for the time that will be shared by our speakers this afternoon in the person of Ms. Marifi Bilando and Ms. Erica Jane David. This GIS technologies has really emerged from the 90s to the latest. I remember when I took my training on the PC. It's PC Art Info before, where it's very difficult. It's very hard for us to map or to digitize a map from NAMRIA. But as time goes on, we have now the ArcGIS, and even some open sources, no, related to geographic information system, and now we have this so-called SuperMap GIS that will be featuring later on. They will be discussing on its features and its capabilities. Now, really, this Internet of Things has a big impact. Even the cloud computing has big impact in our society today, as we want to have a clearer view of the things that we want to know, to determine, no? And I think this afternoon's event is a great opportunity for us to explore further, no? And and for the participants, I just would like you to just sit, relax, and listen to our speakers as they will discuss to us all the SuperMap GIS. So without further ado, no, I just would like to welcome everyone to this big event, and thank you very much to all.
Thank you so much, Sir Noel, for that very warm welcome. And I can see from our chat box that we have participants from the different regions of the Philippines, and even from the different parts of the world. So thank you so much for joining us here, wherever you are. And at this point, we would also like to hear from SuperMap, top GIS software provider in Asia and one of the largest GIS platform manufacturers in the world. Here's a message from Nicole Chan, Regional Manager of SuperMap Asia and Oceania Center.
Yeah. Hi, thank you, Emily. So, hi, good afternoon, everyone. I'm Nico, a Regional Manager of SuperMap. And first, I would like to thank the Mindanao State University Iligan Institute of Technology for this opportunity to share SuperMap latest GIS technologies today. And it is a great honor for me to welcome you all to this webinar. In that virtual conference room, I would like to recognize the faculty, the students, technologists, and innovators for joining us today. With your interest and enthusiasm in technology and innovation, surely we can create sustainable solutions that would profoundly impact the way people live, interact, and do business. So I would like to thank you all in advance because through your presence and participation in this webinar, together we can commit to turning our ideas into actions and contribute to the progress of our society. I hope after all the presentations today, you will be interested in SuperMap technology and be encouraged to use and share the software. Hope you will find new ideas with today's discussion. The webinar is one of the many events and opportunities for collaboration that SuperMap will bring you. Again, welcome and let us all learn from and enjoy this webinar. Thank you.
Thank you so much, Nicole. Moving on to the topics for today's webinar, we are going to have two presentations. If you have any questions while listening to the speakers, please feel free to type it in the chat box below. The technical team will answer the questions in the Q&A session after the presentations. Our first topic is on the introduction to SuperMap's Big Data GIS technology, to be presented by Marife Belando from the Business Development Team of SuperMap Asia and Oceania Center.
Good afternoon, everyone. I am Marife from SuperMap International, Asia and Oceania Center, and I, with our team, were in charge of the business development of SuperMap in the Philippines. Today, I'll be presenting to you the SuperMap GIS 10i Big Data GIS technology. But first, let me introduce to you the SuperMap GIS technology and the company. SuperMap was founded in 1997 by Dr. Ershin Zong, and with that, we now have about 24 years of experience in the GIS field. SuperMap is headquartered in Beijing with 38 branches and offices in mainland China, Hong Kong, and Japan. And as of now, we have over 4,000 employees from all over the world. And we are happy to announce that we have some job opportunities available for you. Should you be interested, just visit our Facebook page, facebook.com/supermapph, or email me directly at marife@supermap.com. This is the China GIS market share in 2015. We can see from this chart that SuperMap became the top 1 GIS software provider in China in 2015. And also in 2019, SuperMap was able to climb as the top 1 GIS software provider in whole Asia. Shown here is the SuperMap partnership map. As you can see, SuperMap has already been promoted in the market in South Korea, Indonesia, Malaysia, South Africa, and also some countries in Europe. And to date, SuperMap has about more than 700 partners from all over the world. Some of them you might already be familiar with, like Microsoft, IBM, Huawei, among others. So SuperMap has also entered the Philippine market, and our business is still expanding. Connect with us through the emails that you see on your screen. So this is the SuperMap products family. You can see here, SuperMap has 3 ranges of products, from Cloud GIS Server, Edge GIS Server, to different terminal GIS. And for different terminals, we provide terminal GIS for components, PC GIS, Web GIS, and Mobile GIS. For PC GIS, we can use SuperMap iDesktop to do the data processing, and then use SuperMap iServer to publish the data to the cloud. And then you can use the data published to develop different technology GIS. For the PC GIS, we provide the SDKs like Java, .NET, C++, and others. And in the Web GIS, we can provide JavaScript and Python. So there are 5 key technologies of SuperMap. GIS, so BITDC. It stands for Big Data GIS, AI GIS, 3D GIS, Distributed GIS, and Cross-Platform GIS. For this webinar, we are going to talk about the Big Data GIS. Now, we will introduce Big Data GIS technology in detail. As we all know, with the rapid development and popularization of Internet of Things, cloud computing, and other technologies, global data is growing exponentially, and all kinds of data are flooding in. We are embracing the era of big data. But now we are talking about Big Data GIS in particular. So what is it? Geospatial big data refers to the big data with geographic location information or implied geographic location information, which has the characteristics of large amount of data, fast changing, multiple types, and low value density. At present, GIS is facing great challenges in the processing, storage, management, spatial analysis, and visualization of spatial big data. Therefore, it is necessary to innovate traditional GIS technology and software products to provide solutions for the deep integration of geospatial big data with business processes and application requirements of various industries. Big data GIS is a very popular technology in the recent years. I believe not only in China, but also in different countries from all over the world. In all the overseas market, they have made a lot of use of this big data GIS. And big data GIS is divided into three parts. I'll be expanding them all as we go along. Let's take a look at the history of SuperMap Big Data GIS. SuperMap began to research big data GIS technology in 2017. We have implemented this technology in 90 versions of products. At present, with the enhancement of big data GIS technology, we have reached the 10i version 2020. With the advent of the era of big data, SuperMap software realizes technological innovation through all aspects of the whole process of geospatial big data, comprehensively expands the support for big data, and forms a complete big data GIS technology system to use this big data GIS. From the core layer of GIS combined with IT big data technology such as distributed storage technology, distributed computing framework, streaming data processing framework, the system constructs the ability of GIS basic software to store, index, manage, and analyze geospatial big data, which greatly reduces the threshold of geospatial big data analysis. As mentioned in the previous slide of SuperMap Big Data GIS history, SuperMap has reached the 10i version 2020, and it is named version 10.1. In this version, we have made some new enhancements to Big Data GIS, including providing spatial big data storage engine, enhancing spatial big data analysis ability, providing rich and cool spatial big data visualization, and supporting a variety of distributed computing resource management. Okay, now let's go to the first part of Big Data GIS, the big data storage. In this section, we'll show you how to manage the big data storage. So here we have many data for resource collection, such as basic geographic data, public thematic data, intelligence, and spatial planning data. The data can be divided into two parts. We have structured and unstructured data. For structured data, this can include vector data, image data, tables, and real-time positioning. Unstructured data, on the other hand, contains a large number of 3D data, image, text, and video data. Now, the question is, how are these types of data being stored in Big Data GIS? There are many distributed spatial data engines that has been developed. SuperMap supports distributed data engines, including PostgreSQL, MongoDB, Elasticsearch, HDFS, HBase, and others. Elasticsearch is used to store streaming data, which are ordered, fast, vast, and continuous. This data generally identify location information such as GNSS data or Internet of Things data, which provides a distributed and multi-user full-text search engine. The engine can achieve real-time search, stable, or reliable, and fast functional requirements. HDFS or Hadoop distributed file system is mainly used to store less updated unstructured spatial big data such as CSV, text, GeoJSON, and others. HDFS is particularly suitable as a data source for distributed computing combined with Spark to meet the performance requirements of spatial analysis based on distributed computing. HBase or Hadoop database is mainly used to store large-scale static and dynamic data such as raster data or the GeoTIFF, vector data or UDB, UDBX, we have shapefile, GDB, and various data types. HBase has strong ability of data query, data reading, and data writing, which is suitable for real-time reading and writing and random access to large-scale data. For example, let's look at HBase. HBase is a very good storage engine for data query and data management, such as update, import, or delete. This is a demonstration of 450 million features stored in HBase and displayed in SuperMap iServer. We can see that it's very fluid, so if you need to display a lot of data, HBase may be your first choice. Big data processing and integration are also important. This architecture shows that SuperMap has capabilities to process and manage different kinds of big data so as to achieve usages for different groups. Python is one of the tools that support big data. SuperMap GIS plus Python is based on GIS kernel and component encapsulation, which has the features of full function, high performance, and cross-platform of GIS. It has the advantages of visual interaction and lowering the threshold of use in desktop visualization modeling. In the recent years, distributed computing is also supported by Geographic Processing Modeler. In this modeler, we can build a very complex model for any spatial analysis and use distributed computing. The work efficiency will be very fast. This geoprocessing modeler can be exported from the desktop and used in the web geoprocessing modeler. Now, let's go to the second part of Big Data GIS, the Big Data Analysis component. These are the core capabilities of spatial big data. SuperMap presents a high-performance GIS computing model integrating kernel, computing, and distributed computing. Spark is fused in the multi-level and multi-granularity distributed computing framework of Big Data GIS is constructed. This improves the performance of GIS core analysis by an order of magnitude and significantly reduces the application threshold of GIS core algorithm under the big data environment. Currently, SuperMap supports a variety of distributed operators, including spatial big data, streaming data, and spatial machine learning data. The new big data analysis operator is mainly used to process and analyze new types of data, such as IT big data, including reconstruct tracks, summarize with grid, summarize attributes, summarize with region, calculate OD matrix, find hotspots, calculate density, detect incidents, search similar locations, join features, spatial filter, attribute filter, build multivariable grid, resident analysis, and many others. And I'd like to introduce some popular algorithms. The first one is hotspot analysis to monitor urban operation in real time. And this is another example of big data analysis in COVID-19 big data decision system. This platform allows hotspot analysis to visualize the intensity of COVID-19 patients in a specific area. It can also create a trajectory map of the data. This is another demonstration of SuperMap and AliPolarDB. It shows the streaming data trajectory construction based on the world's 2.5 billion record flight 4D data or 3D and time. It shows a good visualization effect, and it also supports data on a millisecond level queries. So we have more spatial big data analysis operators such as population boundary analysis, including population size, spatial distribution analysis, and urban development boundary delineation. We have residential space analysis, including spatial structure analysis, public center system and service scope analysis. We have traffic facilities analysis, including road congestion, public transport convenience, and service scope analysis. We also have corridor analysis and work-living balance analysis, including the work-living balance, work-living space, and commuting distance analysis. Based on AI and cellular automation model, we can use the land use pattern from 2001 to 2008 to simulate the land use change in these two periods. So let's take a look at the video. The accuracy of simulation results as 83%. In addition, more accurate results can be obtained through training and sampling, which has important guiding significance for land use planning. Now we are moving from the basic core to the application platform. So I have shown you a while back the SuperMap GIS 10i 2020 product family. Since SuperMap 2000, SuperMap has only one component product. Now in SuperMap 2020, we have formed a cloud edge integrated product system. SuperMap provides a variety of big data GIS basic software product to provide users with big data GIS capabilities. The products include data storage, GIS component, GIS portal and application server, GIS terminal, and operation and maintenance management. SuperMap realizes efficient and stable storage management of geospatial big data through the extension of support of distributed file system and distributed database. And SuperMap provides distributed spatial data storage engines such as Elasticsearch, HDFS, HBase, and etc., providing basis for efficient storage. For GIS components, SuperMap provides SuperMap iObjects for Spark, a geospatial data object to fuse Spark. SuperMap iObjects for Spark not only reconstructs existing spatial analysis operator based on distributed computing technology, which greatly improves the efficiency of massive spatial data analysis, but it also develops a series of new spatial analysis algorithms for big data, which can be directly embedded into Spark, solving the problems of geospatial big data analysis and application. SuperMap iServer provides new data catalog service like geoprocessing, distributed space analysis, streaming data, and other web services. SuperMap has built-in Spark runtime, which reduces the threshold of big data environment deployment. SuperMap iPortal service establishes GIS Big Data Resource Portal, realizing unified management, sharing, and application of enterprise-oriented GIS resources and services. For GIS Terminal, SuperMap provides applications and development packages for PC Terminal, such as the SuperMap iDesktop X. We have web terminals such as the SuperMap iClient JavaScript or Python, and mobile terminals such as SuperMap iMobile for geospatial big data. And for operation and maintenance management, SuperMap provides SuperMap iManager to realize intelligent operation and maintenance management for cloud and big data sites. As I mentioned earlier, SuperMap iServer has built-in Spark, a distributed computing framework. By setting up the SuperMap iServer cluster, the distributed analysis environment can be set up quickly. At the same time, SuperMap supports the existing big data platform of users and quickly integrate the existing Spark cluster of users so as to realize the continuous utilization of original resources and avoid resource waste. SuperMap iServer provides services that are related to spatial big data, including data catalog services, distributed analysis services, and streaming data services. It also supports independent data storage applications, iServer Data Store, and new machine learning and data science services. SuperMap iServer provides services related to geospatial big data, including data catalog services, distributed analysis services, and independent data storage application such as the iServer Data Store. As shown in this figure, users can register the geospatial big data stored in Oracle, HDFS, HBase, and other databases into the Big Data Catalog service to achieve unified management of data. Taking the data as the data source for big data analysis and processing, SuperMap mainly provides distributed analysis service and flow data service in the form of web service, which can quickly analyze and process billions of geospatial big data with even higher orders of magnitude data. Let's take a look at this demo. This is a query for millions of data, which can return the result in just a matter of seconds or in a rapid response. Through the fusion with Spark streaming framework, SuperMap streaming data technology has formed an integrated technical scheme, including data access, analysis, storage, output, and visualization. Streaming data related to real-time data always comes from the Internet of Things layer, such as the mobile terminals, monitoring sensors, GPS devices, social media, and etc. We could import it into SuperMap iServer streaming service, and we can carry out attribute filtering or spatial filtering, and then we can choose to output them directly to different terminals, or we can store them in our data storage or the database. This demonstration uses some distributed big data spatial engines. This is a case based on SuperMap and Alibaba. It monitors the customer location around the world. We can see that the local data is about 2.5 billion. If we want to do spatial analysis, we can easily draw the boundary and get the results. SuperMap stream data technology mainly uses the stream data processing extension module or the streaming service of SuperMap iServer to receive, store, process, and output stream data with spatial information. At the same time, the user interface of flow processing model is provided to reduce the threshold of service management. Users can use SuperMap iClient, SuperMap iDesktop, SuperMap iDesktop X, iPortal, and iMobile to realize flow data visualization. In addition, SuperMap supports the storage of stream data in SuperMap iServer data storage with the Elasticsearch cluster, and the analysis and mining of historical data through the distributed analysis service of SuperMap iServer. Through SuperMap iPortal, users can manage the resources and services of streaming media data and finally realize the visualization of streaming media data on PC, web, and mobile phone. SuperMap Data Science Service integrates with the third-party library. The codes can be edited at Notebook Editor. It is a way to achieve spatial deep learning abilities with customized development. iObjects Python and iClient Python are provided by SuperMap, which provides kinds of APIs for development. These are the capabilities of big data and AI which SuperMap can provide. The analysis operator of AI and big data belongs to multiple spatial analysis. With the advent of the era of big data, people have increasingly urgent demands for spatial big data processing automation and performance. To this end, a unified modeling framework needs to be provided, and geoprocessing models run through geoprocessing operators, which can realize the automation of spatial big data processing and analysis. SuperMap has developed a distributed unified modeling framework for spatial-temporal big data. The distributed modeling framework serves as the basis for building business models in upper-level application software. It includes a wealth of distributed spatial-temporal data processing operators, import and export operators, vector analysis, raster analysis, and distributed machine learning operators. At the same time, it can support users to use multiple development languages such as Java, Scala, Python, and others to customize operators and associate with existing operators. Over 200 distributed computing methods have been implemented in SuperMap distributed modeling tools, and they have been applied to the geoprocessing service or the geoprocessing modeler in server products and the toolbox in desktop products. The Big Data Toolbox based on SuperMap iDesktop X or the geoprocessing service of SuperMap iServer can provide more than 200 orchestration and combination of distributed analysis and processing operators, and realize that spatial data or analysis results based on distributed storage can be directly used by publishing map services. Sub-published to SuperMap iServer map service for web browsing. Now we have come to the third part of the Big Data GIS, the Big Data Management. In Big Data Management, we have SuperMap iManager, that is a comprehensive GIS operation and maintenance management center that can be used for application service management, infrastructure management, and big data management. iManager provides Kubernetes solutions based on container technology, which can one-click create big data, AI, and 3D GIS systems based on cloud-native GIS technology. iManager can monitor multiple GIS data storage, computing and service nodes, or other websites, monitoring hardware resource occupancy, map access hotspots, node health, and other indicators, and realize integrated operation and maintenance management of the GIS system. iManager also can manage, operate, and maintain GIS cloud-native system to realize fine-grained dynamic scaling and flexible deployment. So this is the new big data operation and maintenance management interface in SuperMap iManager, which can monitor SuperMap iServer, SuperMap iPortal, GIS database, cluster, and others. SuperMap iManager can monitor not only GIS resources, but also database servers in other IT infrastructure. It also provides early warning management. For example, if an administrator creates a notification about what happened, such as a database shutdown, a SuperMap iServer shutdown, or an application shutdown, or if a specific resource, such as a CPU, is reaching its maximum usage, SuperMap iManager will send notification to responsible users, such as administrators, through email and message. And I want to show you the advantages of our products compared with other GIS product platforms. In Big Data GIS, our products are better integrated into the customer's existing big data platform. Now, we have entered the last part of Big Data GIS, the multi-terminal visualization. User can use multi-terminal visualization to realize the Big Data GIS from desktop terminal, web terminal, to mobile terminal. From desktop terminal, users can use SuperMap iDesktop X. The SuperMap iDesktop X is a cross-platform full-function desktop that supports mainstream operating systems such as Windows and Linux, providing spatial data production and processing, distributed data storage management, distributed spatial analysis, big data mapping, service publishing, visual modeling, and other functions for data production, processing, analysis, and mapping. After users import the data into spatial big data storage such as HDFS, users can directly view the data stored, or users can perform filter, both an attribute or the spatial filter. This is a demonstration video of data attribute filtering stored in HBase, one of the spatial big data storage. Users can also map the data stored in big data memory, such as HDFS. Mapping operators can be unique value mapping, label mapping, multi-band combination, digital elevation model, and others. So in SuperMap iDesktop X, users can create a map dashboard through real-time access to streaming data. Users can extract statistics, grid visualization, and other indicators from the data itself. This is an example of creating a map dashboard in SuperMap iDesktop the traffic situation monitoring and command system of Henan Province. SuperMap iServer support the map service release or support to publish a map service from the data stored in distributed spatial database engine. Now let's talk about the web terminal. SuperMap integrates open source map frameworks such as OpenLayers, Leaflet, Mapbox GL, and open source visualization frameworks such as the Map and eChart, and encapsulates them into a unified SuperMap iClient development interface to provide users with cool, dynamic, and intuitive visualization effects. Big data spatial visualization not only supports 2D, but also supports 3D visualization. The visualization supports both static and dynamic rendering, and visual rendering effects include dashboard, aggregation diagram, density diagram, heat diagram, and others. We will see these examples one by one. This is the example of static rendering visualization of geographic data. It supports grid map, OD map, road map, and other static geographical visualization. From static visualization, we have dynamic visualization. It also supports the visualization of dynamic data such as the strong boundary map, dynamic OD diagram, trajectory map, and so on. And these are the examples of advanced visualization of geographic data. You can see that the effect is very cool. We can display this advanced visualization both in 2D data or in 3D data. In addition to SuperMap iClient, users can also manage resources and visualize data in SuperMap iPortal, which has a ready-to-use web application. Users can upload data or register resources to SuperMap iPortal. They can be rendered, visualized, or analyzed in SuperMap iPortal. If they want to render or visualize the data, they can use DataViz for online mapping. If they want to represent data in statistics or indicators, they can use the map dashboard. If they want to analyze the data, they can use Data Insight. Data Insight can perform online spatial analysis in SuperMap iPortal. These are the built-in applications I just mentioned. These applications are web applications without code, which means that users do not need to code for any development to create the following applications. The data stored in iServer Data Store can be registered with SuperMap iServer as stream service or data stream service. This can also be read directly by SuperMap iPortal to perform some analysis in the stream data itself in CSV format. It must be published as a stream service in SuperMap iServer, and then it can be accessed in SuperMap iPortal Streaming Data Access for further visualization and analysis. This is how streaming data is being visualized in the web terminal. This video shows how we can easily visualize streaming data that has been published as a streaming data service. We can only need to select the visualization effect and input some parameters to visualize the flow data in DataViz, the built-in web application of SuperMap iPortal. Here we have the degree of contract. We can also use the off-the-shelf codeless map dashboard configuration, which can display data, indicators, and data statistics. These pictures show that the flow data layer of the data block is saved, and the large screen of iPortal map is used for spatial data display. And at the same time, the large screen can also display more attribute information such as flight mileage, aviation punctuality rate, and other information to understand the real-time information of national flights at a glance, which is, cool and clear. Now, let's turn to the visualization of mobile terminals. We can give full play to the advantage of mobile devices. The supported analysis models include aggregation analysis, buffer analysis, density analysis, element connection, grid index, overlay analysis, single object query, region summary, topology check, vector clipping, and etc. We can do the real-time display of the taxi trajectory in the taxi app based on the streaming data, or we can form a hotspot map with our mobile devices. So now let's summarize the advantages of our multi-terminal visualization. So these are the advantages of multi-terminal visualization in SuperMap products. First, we have a rich and cool visual effect from desktop, web, and mobile terminal. Second, web terminals integrate more open source visualization frameworks. Third, from static visualization, we can achieve dynamic visualization as well. And fourth, it can display not only 2D visualization, but also 3D visualization. And for the last one, server computing can be extended to client computing. And that's all for my presentation this afternoon. Thank you very much for your attention.
Thank you so much, Marife. Pretty cool, right? That was just a sneak peek of the applications that can be done with the big data GIS technology of SuperMap. While you're letting all of that sink in, maybe you can also start pondering on how you can utilize this kind of technology in your field or industry. I see a lot of students in our chat box, so maybe you can use this information for your future research, projects, thesis, and other studies. We're excited to hear about what you come up with, and we're very open to collaborating with you to make that happen. For our second and last topic, Erica Jane David from the Business Development Team of SuperMap Asia and Oceania Center will be presenting to us about SuperMap Big Data GIS technical solutions and applications.
So good afternoon, everyone. I'm Erica from the Business Development Team of SuperMap here in the Philippines. So Marife previously introduced you to our company, SuperMap, and one of our key technologies, Big Data. In this presentation, we'll be focusing on Big Data technical solutions and applications, and what algorithms SuperMap uses to achieve these solutions. So for the first part of my presentation, I will be discussing SuperMap's Big Data Analysis component, which is the core component of SuperMap Big Data GIS. The SuperMap Spatial Analysis component mainly introduces hundreds of types of spatial analysis operators. At the same time, it is constantly optimizing the performance of spatial analysis operators, gradually integrating multiple technologies consistent with the deep integration of distributed technology and Spark. At present, more than 40 analysis operators with distributed processing capabilities have been formed. SuperMap supports many big data algorithms using Spark calculating frame like spatial big data analysis, streaming data, and spatial machine learning. We have more than 60 in total, and all these algorithms can be used in the distributed environment. Marife already introduced some of these algorithms, and I will show you more of this in the next slides. First is cluster analysis. Suppose we have many taxi location data, which is displayed as the gray points on the screen. We can use cluster analysis to find the hotspots of the places where people are likely to take a taxi, represented by the colored areas. When we connect this to the map, we can find the specific locations and nearby landmarks. So this is useful for traffic planning and management. Next is origin destination or OD analysis. This is an OD analysis using cell phone signals in the morning and evening peak hours. We have here two places of interest. First is Tiantongyan, which is a residential area in the suburb of Beijing. We can see that people are most likely to leave the area in the morning and go back in the evening peak. Another place of interest is Kuomao, which is the CBD of Beijing. And the situation here is the reverse of that of Tiantongyan. Using OD analysis, we can find the patterns of the people's movements and predict traffic condition between the different districts. We can also apply this analysis to other fields such as public health, for example, the COVID-19, to study the correlation between the people's travel between places and the outbreak. Another algorithm is simple density analysis. In this example, we have set hexagonal as the mesh type. Then we can analyze the distribution of over 13 million points, resulting to 16,000 density surfaces. We can also do point cluster analysis for the 13 million points, also setting the mesh type as hexagonal and a distance of 300 kilometers, resulting into over 1,900 density clusters. For this one, using the data in the China area, we will apply the point polymerization analysis, resulting to 33 polygon clusters. Another one is in the United States. We can do single object query analysis using census data in 2014 and intersecting with Route 66 buffer. We have queried over 20,000 objects. The next one is a vector cutting analysis using the same data and inner cutting as the method. We will have statistics for over 20,000 polygons. Zonal Statistics is a classical spatial analysis algorithm. I think maybe most of you have used it, but for a large amount of data, in this example, we have more than 10,000 basin polygons in North America and 60 years of TIFF annual precipitation data sizing more than 329 gigabytes. We can use distributed algorithms to calculate all of this data at one time. We'll spend only 4 hours to finish this. Another application of density analysis is to calculate the spatial distribution density of the elements, not only in the calculation area, but also its surrounding. Shown here, we use the existing mobile signaling location data to calculate and create the aggregation diagram of the flow distribution, which can assist in base station deployment and network optimization. We can also use location big data to identify the inefficient industrial land and hollow areas. Overlay analysis refers to the construction of filtering conditions through the spatial and positional relations between geometric objects and the query of objects satisfying the filtering conditions from existing data. Shown here is an application where the plan is to build a road across the entire area and to find all the impact patterns. Another is the overlay analysis of Sichuan Bureau of Surveying and Mapping data, with data of over 60 gigabytes and 3,502 square kilometers of irregular polygons. With distributed computing, we can reduce the time to finish the processing from 42 minutes to 2 minutes, improving the performance of up to 20 times. Next algorithm is Geographic Fence, which is the real-time dynamic determination of which targets fall into the selected fence with support for calculation of enter, hold, exit, and other detailed state. We can use this for air traffic control center, cash truck, oil tanker, and other targets for real-time monitoring and fence border. We have here the terrain suitability analysis used for comprehensive analysis for a specific development activity. The comprehensive factors include elevation, slope direction, topographic relief, current construction land, water body, geological disaster, and more. The results are then classified according to the appropriate indicators. This can be useful more in agricultural applications like urbanization site selection, crop type layout, road selection, selection of the most suitable land for restoration, and others. With distributed computing, we can improve the performance up to 50 times. With traditional computing model, a large amount of intermediate temporary data is generated in the process of analysis. But with distributed computing, there is support for function splicing and assembly, and there is no need to store intermediate data. In summary, surveying, mapping, and planning departments handling large amounts of spatial data benefit from SuperMap's technology because of unique component big data capabilities. This includes the SuperMap iObjects for Spark. It is built by standard C++ and combined with Spark technology, which is the big data GIS basic component product based on distributed technology. It allows for component to web big data capabilities, has many operators, and reconstruct classic operators to new operator. So this is advantageous for more scenarios and more industries. Okay, finally, let's take a look at the next and last part of this presentation, which is the big data case applications. The first case is the application in natural land resources. This is a land use big data platform for one province in China. Here is the transportation application, also shown before by Marife, showing the streaming data trajectory construction based on the world's 2.5 billion record flight 4D data. Big data also enhances smart city projects. This is a smart city application integrating a lot of basic geographic data in one application. Here is another smart city operation center developed by SuperMap. You can see that the models here are beautifully visualized in 3D, combining different special effects such as the light effect. If we want to show the model at how it looks like at night, these are all made by SuperMap. SuperMap can also help you develop to create your own special effects. This is then integrated with various data such as the cases, AI video, public issues, and more. And here you can see these 3 targets. And when we click this tag, it will show that there is a car accident and when did it happen. So for managing the city, no need to go to the site. They can see and check all the information in this system. And by integrating to different mobile applications, anyone can access the system to report and upload and update the information on the city. It means you are able to integrate the different data sources with big data technology and to share the information and data in one system. It is also able to integrate with videos and CCTV cameras. By clicking the camera symbol on the system, it will display the real-time situation on that street. We can also manage and monitor for traffic offense. With the use of CCTV cameras integrated with big data technology and AI technology, we can recognize the offense and take a picture, then send to the system. So you don't need to dispatch a police to the road to get the information. We can just use the city cameras to catch and get the traffic offense information. Another one, when we're driving on the road and using our navigation device, we are interested on the real-time traffic situation for different roads. With big data technology, we are able to calculate the real-time traffic situation in city level or even province level and help us make decisions for our routes and travel. So this is the application for one big telecom company in China to show the order location and do some related analysis. This is urban planning data in Shanghai. In this urban planning big data research center project, we adopted the domestic leading SuperMap big data solution and realized the functions of fast and efficient management. calculation and visualization of big data in urban planning through distributed storage and computing environment, which is Spark plus Hadoop. And the function of the platform include analysis, provide decision-making basis for urban planning based on big data of urban planning. And the analysis model of occupation and residence. The visualization of 81 types of data integration, OD visualization of the commuter relationship of a certain city, and other. This is the public security big data platform in Nanjing. The main feature are big data spatial analysis based on vehicle location, police car real-time location management, geofence monitoring, and personnel migration analysis. For the last application, this is a satellite monitoring and tracking ship project. In a ship big data project, users' requirements include first, maintaining real-time location data storage and spatial visualization of 2.8 million ships per day. The next one, realizing efficient storage and custom query of the existing data, which includes 10 billion records. And third, segmenting ship data, about 1.6 billion, in half a year by day or hour, and reconstructing tracks within the time range. In response to the above requirements, SuperMap provides a solution based on streaming data storage technology, streaming data calculation technology, and streaming data visualization technology, realizing real-time monitoring of ship data, reconstruct tracks, and other functions. So that's it for my presentation about big data GIS, SuperMap's key technologies of BitDise. Before we end, let us watch a short video showing the different applications of SuperMap Big Data. So that's it for my presentation. Thank you everyone for listening.
Thank you, Erica, for sharing with us the overview and demonstration of SuperMap solutions with its big data GIS technology. There we have it. Our speakers just gave us a comprehensive introduction to SuperMap GIS technologies in the era of big data. We hope that by this time it's bringing you more ideas on your current projects, research, or business. So far we've received no questions, so we're assuming that you have learned a lot from this session. But if you would like to ask more or you want to just send us a private message, feel free to do so through any of the platforms that you see on the screen. So we hope that this webinar has sparked your curiosity about SuperMap, because we are happy to announce that we will be offering a free trial license to our participants here. Just send us a message or an email, as you can see on this slide. To cap off our event for today, let us hear some closing remarks from Engineer Elizabeth Albiento, Chairperson of the Department of Civil Engineering and Technology of MSU IIT.
Okay, so good afternoon, everyone. Good afternoon, Ma'am Emily. In behalf of the MSU IIT, the co-host for this webinar, I would like to thank all the people who made this event possible, especially to the team of SuperMap GIS Philippines, and to Miss Marife Bilando and Miss Erica Jane. You did a very amazing job, and for sharing their knowledge and promoting this new technology in the field of GIS. I would also like to thank the students and faculty of MSU IIT, GIS users around the world, and collaborators of SuperMap GIS for all taking the time out of your busy personal and professional schedules to join and support us. I hope that what you learned today will enlighten your ideas on new technologies, especially on the idea of Internet of Things, cloud computing, and other technologies. Again, thank you everyone, and happy learning. Go, go GIS.
Yes, that's true. Go GIS. So we really want to encourage more people, not just those in CE, GE, or the stereotypical sectors that use GIS. We encourage everyone to utilize this awesome technology. So thank you for that, Ma'am Beth. And thank you, everyone. We highly appreciate your attendance today. Feel free to visit the SuperMap website to get more information about the company. We also invite you to follow SuperMap GIS on Facebook, Twitter, and LinkedIn, because we are constantly posting about the latest GIS trends and what SuperMap is currently up to. And for our local SuperMap company, we have SuperMap Philippines Facebook page, and we also have a community on Facebook. It's a group called SuperMap Philippines Community, so feel free to search it on your Facebook and feel free to join. So we are excited to welcome you there. And again, for the students, we are inviting you to join SuperMap's first ever local GIS contest in the country, Tagisan. You might also be interested to become one of our university ambassadors, where you will become part of the SuperMap team, where you will represent your university. More benefits are indicated on our Facebook page, so make sure to like and follow SuperMap Philippines. Again, thank you for attending this webinar, everyone. Don't forget to answer the evaluation form, which you can find in the chat box below, so we can bring you a more improved webinar experience. Expect your certificates in a few days as well via email, and you can find the link on the chat box too for the forms to your certificates. And SuperMap will hold more webinars on more topics soon, and we hope to collaborate with MSU IIT again, of course, and with even more universities in the Philippines. So we will virtually see you soon in the next webinar. So for now, happy weekend, goodbye, and have a great day.